Okay, so now we know how to use Pythagoras' theorem to find the unknown side of a triangle. We can now apply that to more real life problems. Okay, so problems involving Pythagoras aren't always going to give you a nice little triangle that you simply put the numbers into Pythagoras' theorem. Sometimes you'll actually need to create a triangle yourself. Okay, and that is part of the skill of being able to solve those problems. Okay, so from the information given, we need to draw a triangle. On the triangle, we need to insert the given measurements. Now, you'll be given two measurements. You need to determine which two sides of the triangle you have. Okay, then based on where you put your measurements, you need to work out whether you're finding the hypotenuse or a short side. And then, of course, we'll solve using Pythagoras. So once you've got your triangle drawn up with all the relevant information on it, you can solve using Pythagoras' theorem as normal. Okay, so I have a couple of problems here. The size of a TV screen is described by the length of its diagonal. If a flat screen TV is 58 centimeters wide and 32 centimeters high, what is the size of its screen? Answer to the nearest centimeter. Okay, so if you didn't know this, the size of a TV is in fact the length of the diagonal, so from the top corner to the bottom corner. I'm just going to draw a TV, okay, because that's the problem I've been given. All right, there's my TV. It's beautiful. It's straight, okay, and what I have here is diagonal. Remember, diagonal extends from one corner to the opposite corner. I'm told my TV is 58 centimeters wide and 32 centimeters high. Okay, I now have a right angled triangle, don't I? Okay, my two lengths of the TV plus my diagonal. Of course, my diagonal is my hypotenuse. That's what I want to find. Let's see what it is. So I've got c squared is equal to 58 squared plus 32 squared. Remember, the opposite of squaring is square rooting. So to get c as opposed to c squared, I need to square root the other side. So 58 squared plus 32 squared. And when I pop that in my calculator, I get c is equal to 66.24. To the nearest centimetre is the detail that I've been asked to show. So of course 66.24 is closer to 66 centimeters. Okay, so that's the size of the TV. Okay, then we have a tower is supported by a wire that is 20 meters long and attached to the ground 10 meters from the base of the tower. We want to know how high does the wire reach up the tower. We want to answer to the nearest 0.1 of a meter. Okay, so I have a tower and there is a wire that is attached to the ground. And then obviously I have my ground extending between the bottom of the wire and the bottom of the tower. So my wire is 20 meters long. It's attached to the ground 10 meters from the base of the tower. So it's attached down here. That's 10 meters across. Look, if your triangle is not to scale, obviously if that was 20 meters, that is not 10 meters. It's okay, as long as the information is in the right spots. It doesn't have to be super duper accurate. Okay, so then I've got my information on my triangle. I've worked out that I need to find the height of the tower, which is one of the short sides of the triangle. I'm going to use H for height. Okay, I could use T for tower. I could use A because it's a short side. Honestly, it doesn't matter as long as you do introduce a letter. Okay, please don't use a question mark or nothing at all. All right, so now I'm going to input my information into Pythagoras' theorem and work out the height of the tower. So we know h squared is equal to 20 squared minus 10 squared this time, because obviously we are finding a short side, so we need to subtract. The opposite of squaring is square rooting, so that's how I'm going to get h on its own. So I need to square root my other side, which is 20 squared minus 10 squared. So our height of our tower is equal to the square root of 20 squared minus 10 squared. which gives us 17.3205. Now I've just written those extra digits to show you how to correctly round. We want to answer to the nearest 0.1 of a meter. This is in meters because our 20 is representing meters, our 10 is also representing meters. So it means we have our height of our tower is 17.3205 meters. I want it to the nearest 0.1, so that means I want to keep one decimal place. So I want to cut it off there. Look at my critical digit. My critical digit is 4 or lower. So what that means is this is actually going to stay as is, as 17.3 meters high. Okay. So super important, draw a triangle. Don't try and save time by just quickly inputting the values into Pythagoras' theorem, because you want to make sure you are using the correct process, depending on whether you are finding a short side or a hypotenuse. Okay, give us a thumbs up if this video was helpful for you, and remember, subscribe to my channel so you can get notified when I upload new videos.